Okay. Oh no, goodness. All right, so we're going to continue on with the rest of notes 47. We ended here with the acid base's characteristics. Now we're going to go through how to name an acid base. It has been quite some time since we went over how to name compounds. So it was more towards the beginning of the year. But we're going to finish up the naming process right now with how to name an acid and a base. We've already done naming. I feel like it's going to be pretty simple because there's just some pretty short rules about how to name them, name an acid or base. And we're just going to go through it right now. Okay. So again, from yesterday, remember a base is something that has a pH that is greater than 7. So from 7 to 14 is things that are basic. They have hydroxide ions. So anytime you see these hydroxide ions, this is an exception to the rule. There's always at least one exception. But most of the time you're going to see those hydroxide ions, and that is what makes you know it's a base. Now, when it is a base, the rule is name them like any other, it's all not calibrated, name them like any other ionic compound. So when it's that just means name the metal as is, name the non-metal, but you change it to "ide" if it's by itself, or it's a polyatomic ion, which it usually is because it's a base, so it's called hydroxide. So that OH you're seeing in all of them is called a hydroxide. That's a polyatomic ion called hydroxide. All right, so how we name it is we just name the metal. So Na is sodium. Leave as is. Now, the only thing that might happen is sometimes a metal might need you to have the charge as a Roman, I need more room here. Charge as a Roman numeral. And you might remember those Roman numerals for 1, 2, 3, and 4. I'm going to remind you how to do that with the next two. But for this first one, sodium is in the first two columns. So it does not need Roman numerals. We know its charge, but I just name the metal as is. And then the OH, we tack that on. So that's a polyatomic ion called hydroxide. So we don't change its name or anything. It just is hydroxide. So hydroxide. There we go. Now the next one, barium. So again, we name the metal. So Ba is barium. Okay. We're going to have hydroxide, but I do need to check to see if I need Roman numerals. So Ba, barium, is also in the first of the two columns. So first or second column, we don't need Roman numerals. So I still don't need Roman numerals. I know its charge is at +2. So I just named the OH, which is a polyatomic ion called hydroxide. There we go. Now the next one, Fe, is iron. Why is it writing so much higher than where I write? Okay, try to write it way down here, and then it goes way higher. All right, so iron, I do know that iron is a transition metal. It's in the middle of the periodic table. I don't know its charge. It has variable charges, so I'm going to have to figure out its charge and put it in Roman numerals. So I'll leave that parentheses there to figure out in a second. And the OH, again, you just name by either changing to IB or it's a polyatomic ion, which this one is, it's hydroxide. So I'm going to write hydroxide. Now, this polyatomic ion is the only one you're going to need to know for bases. Hydroxide has a -1 charge. It's so much higher than where I'm writing. All right, has a -1 charge. So I need to figure out what this iron's charge is based on the fact that I know hydroxides is a -1. Well, there's 3 of them, right? There's 3 of them, so that'd be -1, -1, -1. That's 3 -1s. So that's a -3 total charge. Well, there's only one iron. So that one iron has to have a charge that's going to balance all 3 -1 charges. So it has to be a +3. So +3 -3 makes it a neutral charge. So this iron has a 3 as the Roman numeral. This is iron 3. It's an iron with a +3 charge, hydroxide. So there you go. So that happens for all the metals in the middle. It's a metal in the first 2 columns. So I'll put that over here. Metal in columns 1 or 2. Columns 1 or 2. No Roman. It's like I don't have enough room to write this all. easier to write on these boards. So these two metals in columns 1 or 2, no Roman numerals or no Roman numeral numbers in the middle. Okay, so those first two didn't need it, but the iron did. Now this last one is an exception to the rule. It doesn't have that hydroxide on it. It's just one you have to recognize. So it's the only one you're going to have an exception for bases. If you see an NH3, that is called ammonia. So it's a cleaning solution. NH3 is ammonia. It is a base, but it doesn't have the hydroxide ion attached to it. Okay? All right, now how to name acids. So there's acids are a little more complicated. That's that for bases, it was the same as we named ionic compounds. It really was no different. But for acids, there are a couple of different rules. So because there's several different types of acids. So for the first part, we're going to go through binary acids. So binary means it only has 2 elements. Now, if you go back from yesterday's notes, remember they're all starting with hydrogen. So if they start with a hydrogen, it's probably a good indicator that it's an acid. It's fine. It has 2 elements. So the rule for these, if I'm trying to follow the rules, it says I'm going to put a hydro. So hydro, and then the root of the this one. So not hydrogen. Hydro is for that. The root of my second element. So my second element is fluorine. I'm not going to write the whole word fluorine. Just put the root of it. So hydro, fluor. So instead of fluorine, just fluor, and then a tack on ic. A little out of room, so I'm going to put acid down here. So hydrofluoric acid is what it's called. And that's just how you do it. So there's only 2 elements. Then you put hydro, you put the root part of the second element, so fluorine is fluor, and then tack on it. So hydrofluoric acid. Next one, I'm going to put hydro. So this one's chlorine, so I'm just going to put chlor. Instead of chlorine, we'll just put chlor. Then ic and acid. So hydrofluoric acid. And you've probably heard it before. That's just HCl. Normal one we've used in class. We just dilute it. All right, last one. So again, 2 elements. So I'm going to put hydro. The S is sulfur. So instead of putting sulfur, I'm just going to put, actually, for sulfur, it's one of the weird ones. You actually put the whole thing. So chlorine is a longer word. Sulfur, you actually use the whole thing. If you get confused on spelling, you can always ask. I don't usually take off that much for spelling. So as long as you remember the hydro and you tack on the ic, then you're following the rules pretty well. I'm not going to count off that much if you misspelled the root part. So hydrosulfuric acid is the same. Okay, so that's how you name acids that are only 2 elements long. Now, it does get a little more complicated if they have more than 2 elements in the compound. So let's scroll down. Yeah. Got some exceptions. Okay. I think we went too far. Oop. No, that's far. Okay. Okay, so these all have more than 2 elements, and they're all going to have oxygen in it. So they're called our oxyacids. So more than 2 elements, and they're going to have oxygen in it. So there are oxyacids, and this is how they are named. So first off, it depends on how many oxygens they have. So we name them based on the number of oxygens they have. So this first one has 1 oxygen. So I'm going to follow this rule. So I'm going to put hypo at the beginning, the root of the element that isn't oxygen. So the second element still. So fluorine would be fluor, just like it was a bit up there. So hydro, I'll put flour, not fluor. Bad. Now look at that. Okay, so hypo, fluor, and then it says us, hypofluorous acid. So that's the difference. Up there, it was called the ic, so hydrofluoric. Now it's hypofluorous acid, and that's telling me the us is a different term for things that have an oxygen attached to it. It only has 1 oxygen because hypo means less. So that's just a prefix meaning less, so it's going to have less oxygens than the other ones. All right. I want to have an example of 2 oxygens. That's dumb. Okay. Okay. So if you had two oxygens, you would leave off a prefix word and you would just start with the second element root and tack on us and then acid. But let's try a 3-1. We got a 3-1 down here. So this one has 3 oxygens. So the 3 oxygen is, I don't have any prefix. I start with the root of the second element. So carbon is actually weird like sulfur. So it's going to actually have the whole thing. Carbon and sulfur are the weird ones. You actually use their whole name. So carbon, but it says it's carbonic. So carbonic, tack on acid. And there we go. That's what we named it. This one also has 3 oxygens. We're named it the same way. So again, I don't need a prefix. I'm just going to go with the root of that. So nitrogen, I'm going to put nitro. The root of nitrogen. Tack on ic. So yeah, that sounds weird. That's what it is. So nitroic acid. Oh, I know. This doesn't have the O. That's why it sounds weird. I'm just like, why does this thing sound like I haven't heard nitric? See, doesn't need that O. So spelling, I'm not going to be super mean about it. It's kind of hard to remember what their roots are. So it's just nitric acid. There we go. That sounds right. Now, this one has 4 oxygens. So I'm going to follow this last rule, which says it does need a prefix again. I'm going to put per. Per is a Latin prefix for more. So it has the most oxygen. So per. The root of the second one, so bromine, that'd be brom. So per brom, ic, that's what it says. So per bromic acid. And there we go. So you just follow the rules. So you just look at how many oxygens there are, you follow the rules. That's how you name it. There you go. Let's scroll down and look at some exceptions. Because like always, there's always exceptions. I want to let these slide down without walking over here. So talk about some exceptions to the rule, and then it's done. Now, for these exceptions, you just have to recognize you will get to use your notes on quizzes and tests on how to remember how to name these. These exceptions will be there. You just got to remember to look for them. So the exceptions to the rule are this. They are not named according to the rules for whatever reason. Whoever named them, they named them using different rules. So we have sulfurous acid, sulfuric acid, phosphorus acid, phosphoric acid, and acetic acid. They're weird. If you see these compounds, you just got to remember to look at the list, and that's its name. Okay. All right, so from looking at the name of a substance, how can you tell if it's an acid or a base? Okay, so that's easy. If it's an acid, it starts with an H in the compound. So it's like HCl, HNO3, like that. From a base, so a base generally ends with an OH. So they're going to have an OH at the end on these base. Now, as of their names, their actual naming is going to be called hydroxide. So you're going to see hydroxide in the compound. That's a base. And for these, it's going to end in us or ic. You haven't seen those endings before in our naming. So if it ends in an us or an ic, that's telling you that it's an acid. From looking at the formula of a substance, how can you tell it's an acid? Oh, I just answered both questions. Okay, so up here, this one should have been the answer. So if I'm reading the name and it ends in an us or an ic, that's how I know it's an acid or a base. If it ends in hydroxide, I know it's a base. So the first one, us or an ic, it's an acid. If it ends in hydroxide, it's a base. This one goes down here. So how if I'm looking at a chemical formula, it's like HCl. So it starts with H. Or it's like NaOH, sodium hydroxide. So it ends in an OH. So this is a base. This starts with a hydrogen, and so is an acid. There we go. Now, let's do a little bit of practice. It's the same kind of practice that you're going to do on your worksheet. I'm going to hold up my notes. So it's hard for me to scroll up and down. As you can see, I have to walk all the way back to my desk where my smartboard does not let me easily scroll up and down. So you can look at your notes and scroll up and down and go see it. I will be telling you what I'm seeing. on my printed sheet that I have. I'm just looking at my rules, okay? So I'm looking at it. These all say they're acids over here, so I'm just gonna follow my rules. So it ends in an ic and has a hydro. So that fits the first rule. Binary acids, only 2 elements. They have a hydro. It's the only one that has hydro, and it ends in ic. So I know that it's gotta start with an H. Let's find it right here. I'm going to start with an H, bromic, so that's bromine, is Br. Okay? So I know that it's HBr. Now, I do have to worry about balancing their charges. So a bromine on the periodic table has a -1, so the -1 column, and hydrogen in the +1 column. So they're good. I actually don't need to cross down their numbers or anything. It's just going to be HBr. Okay, next one is perchloric acid. So that was down. The only one that has a per on it is the 4 oxygen rule. So I know it has 4 oxygens. So I can go ahead and put 4 oxygens because that's what that per tells me. The per is the only one that has 4 oxygens. And then chloric, so I know it's going to start with H because it's an acid. Chlor is chlorine, so we got Cl. And there we go. So we know it has 4 oxygens and it's chlorine. There we go. So the only one you have to balance the charges for is ones that are starting with hydro, that have only 2 elements. If they have only 2 elements, you're going to have to balance their charges. Otherwise, you know what they are because it tells you how many oxygens by just following the rules. All right, this one doesn't have a prefix, so it's got to either be 2 or 3 oxygens, but it ends in ic, so that's the 3 oxygen. So this is the 3 oxygen rule. So I automatically know that it's going to end with 3 oxygens. And fluor is fluorine, and all acids start with an H. So there we go. HFO3. Then we have phosphoric. This is actually same rule. Oh wait, no, this is an exception to the rule, isn't it? Phosphoric is an exception. Yes. Okay, so I noticed it. I remember. Phosphoric is actually one of our exceptions. So it's just one you kind of have to remember as an exception. Can't spell exception all of a sudden. Exception. So I go back and in my notes, it says phosphoric acid is H3PO4. That's what it says it is. So that's what it is. Done. Okay. I'm going to do the other 2 acids and then we'll do the 2 bases. So I know these are both acids because we're one. They tell me they are. Hypobromous acid. So hypo only showed up in the 1 oxygen rule. So it's going to have 1 oxygen because that's what that hypo is telling me. Brom is bromine. So it's going to have bromine. All acids start with hydrogen. So HBRO. There you go. Should have wrote them a little closer together to look more right, but that's what it is. All right, idios acid. That's funny. Funny named. Okay, so it doesn't have a prefix, so that must mean it's either 2 or 3 oxygens, but it ends in os, O-U-S. So that falls into our 2 oxygen rule. So I know it's going to have 2 oxygens. So it's going to start with an H because it's an acid, and then idios. Okay, the one that I think when we look at the non-metals, they're all non-metals. Idios is close to iodine. So that's what it's talking about, iodine. Iodine symbol is iodine. Okay, now we got 2 bases. So the bases, they are done the same way that we did ionic naming. I'm really not even teaching you anything new. You've seen these before when we did ionic naming. Just now you know it's a base because bases end in hydroxide. But it's not actually new knowledge. We have done this before. Okay? So for ionic naming, what you do is you write their charges above them, crisscross them to figure out how many of these little numbers you need. Okay? So subscripts. So aluminum, I look at the periodic table, is Al. It has a +3 charge. Hydroxide, which is the polyatomic ion for what bases have, is OH. And I told you up above, the hydroxides have that -1 charge. So they do not balance. +3 - 1 is a balance. I'm going to crisscross them down. So that 3 comes over here, but I need 3 hydroxides. And that 1 comes the aluminum. I know that looks really terrible. I'm going to try to rewrite it. The closer I get to the edges of my smartboard, it looks even worse. Al, that's it starts being crazy. Don't really get why, but it's Al, OH, 3, and that OH in parentheses. I cannot make it look like an H. There we go. Okay, so AlOH3. Goodness gracious. All right, let's try this copper one. So copper 2, if you remember the Roman numerals, tells me the charge. So this copper has a +2 charge. The hydroxide is the only thing that bases have. So it's going to always be hydroxide. It's always going to be OH. And it always has a -1 charge. And that's not going to change. It's just what the base polyatomic ion is. Now, these also didn't balance. So I'm going to crisscross them. So the 2 is going to cross down to the OH and be in parentheses. So 2 hydroxides, not 2 hydrogens. And copper's symbol is C. There you go. So Cu, OH, parentheses around the 2. All right. So what do you think would happen if I have an acid and a base and I mix them together? So basically, you got to think, so pHs. If I have a pH, an acid with a pH of a 2, and I mix it with a base that has a pH of a 8 or a 9, let's say a 9. Okay, well, neutral is 7. So as I mix them together, they're going to get closer to a neutral pH. That's what's going to happen. It's called neutralization. So if I mix an acid with a base, they're going to kind of both neutralize each other. If you put equal amounts, enough of each one, then they'll be completely neutral and they won't be acidic or basic anymore. It'll just be a neutral solution. Okay, done with naming notes. It will let me end it.